In the previous videos, we have understood how to generate the default mesh. Also, we have understood about relevance and its uses. Now we will continue to learn about some other meshing tools. So now we will discuss some more tools like the global mesh settings and the other mesh settings that are available in Ansys Workbench. And while we are discussing about these global mesh settings, we will also understand how to give the element sizes. There is something called as advanced size function available in the global mesh settings. We will also be discussing about that. And then we will also discuss about mesh metrics, that is how to check the element quality. Once the meshing is done, we need to understand whether the elements that we have generated are of good quality or not. So for that we will understand about the mesh metrics. And then we will talk about how to assign the assembly contacts. That is, when we are working with assemblies, how to give the contacts between the two bodies that are available in the assembly. And the another topic that we will be discussing about in mesh settings is how to optimize the geometry. So geometry optimization is another topic that we will be learning. So now let us talk about geometry optimization. What exactly is geometry optimization? Okay. Now in FEA, meshing is a very important concept that we need to understand. And along with meshing, you also need to understand the accuracy of the elements. So if the mesh quality is good, the accuracy of your results will also be good. That means the accuracy of your results depend on the meshing. So if the models are very complex in shape, it becomes very difficult to mesh them. And creating 3D elements takes a very long time, and thus it increases the complexity of the solution. Therefore, once the geometry is ready and it is ready to analyze, you should always simplify the geometry wherever it is possible. Simplifying the geometry is called as geometry optimization. So let us understand how to perform geometry optimization. Now look at this model on your screen. It is a 3D component, it is a clamp. Okay. Now first what we will do is we will mesh this model and we will see how the elements are being generated if I don't optimize this geometry, and if I optimize the geometry, what will be the mesh results. Okay. So let us go to the software. Let me add one mechanical model over here, a standalone mechanical model, where I will import this geometry. Okay, then we will enter into the design modeler. We will set the unit system over here, and then I will generate. So once the geometry has been generated, you can see the geometry on the screen now. Now if you look at the geometry, it is a very simple model. It is a clamp that we have imported. Now let us take this geometry into the mechanical model. So I'll double click on the mechanical model so that we enter into the mechanical window. And now using the default mesh settings, we will mesh the model. So first case what we will study is we will study how the mesh is being generated if the geometry optimization is not done. Okay, fine. So let us come to this mesh option and we will say update the mesh so that the mesh is generated. Okay, now look at the mesh that has been generated. Okay, let us have a look at the number of elements and the number of nodes that has been generated. Okay, now earlier we have studied in the previous lectures that in 3D elements, in 3D volumes, there are two major element shapes, that is tetrahedral and hexahedral. The current shape that you are able to see on the screen is actually a tetrahedral element. These are all tetrahedral elements which are having 4 sides, 4 faces. Okay. So out of the two shapes, that is out of hexahedral and tetrahedral, hexahedral elements are much better and will give us much better and accurate results as compared to the tetrahedral elements. Hexahedral elements can fill a volume more efficiently than the tetrahedral elements. The tetrahedral elements will take approximately 5 to 6 tetrahedral elements to fill one brick. So there will be fewer hexahedral elements required to fill the entire volume. So if the element numbers are lesser, the solution time will also be lesser. That means you will get faster results. But there is also one more thing that you should understand, that if you want to get hexahedral elements, it will take more time to generate these hexahedral elements because you will have to optimize the geometry. Okay. Also, when you create the hexahedral elements, the transfer of the loads from one element to the other is also much better. Okay. So because they are well connected, the elements are well connected to each other in hexahedral elements, the transfer of loads is much better as compared to a tetrahedral element. And when you generate tetrahedral elements, the body slightly becomes more rigid as compared to the hexahedral elements. So that is why your first aim, whenever you start meshing, the first aim that you should have is to generate hexahedral elements. Wherever it is possible, you should always generate hexahedral elements. Now in this case of our geometry, in this geometry we have seen that we have not achieved the hexahedral elements because the geometry is slightly complex to achieve hexahedral elements. So if I want to achieve the hexahedral elements, I need to optimize my geometry, or I need to edit my geometry in some cases. So let us understand how to optimize this geometry. First, let us understand, if you want to achieve the hexahedral element shapes, what should you do? If you want to create hexahedral elements, you need to have a sweepable geometry. Now what is the meaning of a sweepable geometry? Okay. Now imagine you have a simple object like this. We have a base plate . Okay, this is my base plate, and we have a boss feature like this. That is, we have a cylinder like this. Imagine this is a volume that we have. Now this is one single geometry that we will be having. Let me erase this over here. Okay. Now let us say this is the geometry that you have. Okay. Now again, in this case, if you try to mesh this geometry, which is a whole geometry, you will not achieve tetrahedral elements because it is not a sweepable geometry and it is not a uniform structure. So on this geometry, if I want to achieve the hexahedral elements, what should we do? We need to convert this geometry into a sweepable geometry or a uniform geometry. So what I can do for this is, I can split the body over here. Means if I look at the front view of this model, it would be like this. So what I can do over here is, I can split my geometry over here. If I split my geometry over here, what would happen is, I will get two separate geometries. That is, one is a cylinder and the other one is a rectangular plate. So this cylinder is the first body and this plate is the second body. Now when these are two separate bodies, what happens is, this is one sweepable geometry in this direction where there is no discontinuity, it is one uniform structure in this direction. Similarly, this base plate is also sweepable in this direction, that means it is one single plate. So with this, now I can generate hexahedral elements. Okay. So similarly, if you apply the same knowledge on this geometry that we have on screen now, so in this geometry, if I want to achieve hexahedral elements, I need to convert this into sweepable geometries so that they become uniform. Now for doing that, what I would have to do is, okay, look at this geometry. If I cut the geometry over here, if I split this geometry over here and over here, what will happen is, these two flanks of the clamp will become separate and this geometry over here will become separate, due to which I will have three geometries or three bodies in this model, and all the three bodies will be uniform. Now let us see how to split these bodies. So the first tool that we will be understanding in geometry optimization is the slice tool. The slice tool can be used to split the geometries or split the model into multiple bodies, multiple uniform bodies or multiple sweepable bodies, which will help me to achieve hexahedral meshing. Okay, so let us go to the slice tool. Now when you say slice, there are multiple options in slice. We have slice by plane, slice by offset faces, slice by surfaces, slice by offset edges, or slice by edge loop. Out of this, now in current case, I can use the slice by plane or slice by surface. First, let us understand the slice by face option. Slice by plane. So for that, first I need to have a plane over here. For that, what we will do is we will create a plane over here. I will say I want to create a plane from the face, and now I will select this face. I don't want to offset this plane in any direction, so I will just say generate. I have achieved one plane over here, if you see. Now I'll use this plane to cut the body. I'll go to slice by plane option. The base plane is plane number 4, and I will say apply, and then we will say generate. Now please understand, currently we have only one body over here. As soon as I say generate, I get 3 bodies. So I get this flank, I get this body, and then this is the other flank that I have. So this is one single, okay, let me hide this body, let me hide this body. So if you see, this is one simple geometry, which is one uniform structure, which is sweepable in this direction. Then again, if you look at this body over here, if you look at this body, again this is simple extruded geometry. That means it is sweepable in this direction. So what we have got is, by using the slice tool, we have got 3 separate geometries. Okay, now they look transparent, so I will just switch off this frozen body transparency so that they look opaque to me. Okay, now next, if I watch very closely over here, I have 2 faces over here. There is one edge that has got created over here. Okay, now this edge again forms a discontinuity in this direction. That means what I can do over here is I can merge these 2 faces so that they become one face. So for that, we have in tools, we have an option that is called as merge. This merge tool can be used to merge edges, or they can be used to merge faces. In the current situation, I need to use it for merging faces. So I will select merge faces and now select the faces. Use your control key to select the multiple faces and say merge, and then say generate. You can see over here that the 2 faces have been merged. Similarly, the same can be done on the opposite side. Once the merge is applied on the opposite side, this is the result that we've got. So now we have merged both the faces on both the sides. Okay, now once the optimization is done, in this case what we have done for optimization is we have sliced the geometry so that we can get hexahedral elements, and then we have also merged the faces over here. Okay, now let us go back to the model. Here it will ask me whether you want to refresh the data. I will say yes over here. Okay, let the geometry get updated. Okay, now once the geometry has been updated, we will again come to meshing, and here again we will go for default meshing only. I am not changing anything. I'll go for default meshing. But now in this case, because we have sliced the geometry, you can see over here that everywhere we have achieved the hexahedral elements. Okay, so if you have sweepable geometries, or if you have uniform geometries, the default meshing, the first meshing that you generate, will always give you hexahedral elements. But if the geometry is not sweepable and not uniform, the default meshing will give you tetrahedral elements. So this is how you can use the slice tool and the merge tool for geometry optimization.